Hey boys, we're back at it again here. Hopefully you guys had a chance after last night's homework to check out that key that I posted on Mudge. Like I said, tomorrow on Friday, make sure you guys bring your charged laptops and headphones to class. We will be doing a Zoom check-in. I'll hop in and we will go over anything you have questions on that we've covered in the last 3 days via these video lessons. Today we're going to talk about 6.6 and proportionality theorems. So when we have triangles, we're going to specifically talk about the triangle proportionality theorem, which says if we have a parallel line to one side of the triangle that intersects the other two sides, then it divides the two sides proportionally. So if we look at this diagram here on the right, we have triangle QSR, and intersecting QSR is segment TU. TU is parallel to QS, and it intersects QR and SR. So it does follow our triangle proportionality theorem. So what we can conclude from this is, I'm going to cross this out just because it's wrong. We're going to go, if TU is parallel to QS, which it is in this triangle, then we can conclude that QT over TR is equal to SU over UR. We can conclude that these segments on the triangle are in fact proportional. Now the converse is also true. So if we take the same triangle, but now instead we are not told that TU and QS are parallel, but instead we are given that QT over TR is equal to SU over UR. If that's our given, then we are able to conclude that QS is parallel to TU. So both ways work. If we're given parallel lines, we can conclude proportional sides. If we are given proportional sides, then we can conclude that the two lines are parallel. So, as we take a look at a couple examples here, number one, part A, we'll walk through this one together and then I'll give you guys an opportunity to try B. So, find the length of QU. So we're looking for this here, we'll just call this X because that is our unknown. We know that QS is parallel to UT. So because these lines are parallel, we know we have proportional line segments here. So we can just set up our proportion. QU, which is our unknown X, over QR, which is 10, would be equal to 6, which is ST, over SR, which is 12. Now we just have a proportion that we can solve using cross products. X times 12 is 12x. 6 times 10 is 60. When I divide this out, both sides divided by 12. We get x equals 5 here. So we know that our unknown side, or QU, is now equal to 5. Why don't you guys go ahead and pause the video, try B, and then I'll walk through it with you and make sure you're on the right track. So as we look at B, almost the same setup as A. We've got our parallel lines here. So our proportion would be 18 over, we've got our unknown KLX, is which we're looking for, so that is X, equals 24 over 44. If we use our cross products here, I'm going to reduce first, just because it's going to make our lives a little bit easier here. So I know 4 goes into both of these. 4 will go into 24 8 times. It'll go into 44 11 times. This is going to give me 8x equals, let's see, 18 times 11 is going to give us 198. If I divide this out, x is going to end up being 24.75. So not a whole number here, but we still know that the value of x is going to be 24.75. Let's just run through that one more time, make sure we got this right. Oh, we did something wrong as I'm looking at this. Let's go back real quick, double check our math. So go back to our original proportion here, because we should get a whole number, I believe. One of you guys is probably yelling at the screen for something that I did wrong. So we got 24 over 44. 24x equals 18 times 44 is 792 divided by 24 is going to give us x equals 33. So the value of x here is going to be 33, which would make sense. It's going to be a little bit smaller than 44 because 18 is a little bit smaller than 24. All right, and number 2 here. The only part of this that you're missing is this just says, I know it got cut off here, determine if QT is parallel to RS. So if we're trying to determine if these lines are parallel, we're just going to have to prove that our sides are proportionate. So we just have to set up a proportion and prove that it is a true proportion. So our proportion here would be 18 over 38 is equal to 36 over 80. And now we can either use cross products or we can just reduce. Probably easier here. Let's just use cross products on this one, and we can go from there. So if I use my cross products, 18 times 80 is going to give you 1,440 equals 36 times 38. $1,368. So because these are not equal numbers, we know that these side lengths are not proportionate. So this, we can say that QT is not parallel. QT and RS are indeed not parallel because the side lengths are not proportionate. Go ahead, pause the video, try part B here, or example B. All right, so as we take a look at B, let's go ahead and label. So we have AB, we know is 31 millimeters. BC here is 19 millimeters. CD, 27 millimeters. And DE, 23 millimeters. So to prove that these lines are parallel, got to set up our proportion. So let's go 27 over 23 is equal to 19 over 31. Just by looking at this here, guys, it should be very obvious that these are not going to be proportional. In this first ratio, the numerator is larger than the denominator. In our second ratio, the numerator is smaller than the denominator. So these are probably not going to work out, but let's use our cross products just to prove that they will not be. So 27 times 31 is going to give us 837 is equal to 19 times 23 is 437. So as we said, these are not going to be parallel. This is not true. The converse does not work for either one of these examples. And as we look at our final 2 things that we're going to discuss today about proportionality, the first one says if 3 lines are parallel and they all intersect 2 transversals, then they divide the transversals proportionally. So I've got my 3 parallel lines going vertical here. I've got my transversal L and my transversal M. These parallel lines are going to divide the transversals proportionally so that these segments here in the inside of the parallel lines are going to be our proportional segments. So UW, which is this first one up here, over WY, is going to be equal to VX over XZ. So that's our first proportionality idea that we're going to talk about. And then the second one that we're going to work through on this back page is if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other 2 sides. So if we have an angle bisector here, okay, which CD is an angle bisector. It divides angle C into two congruent angles. Then we know AD is proportionate to DB over AC, or this second side here, is going to be proportionate to CB. This will give us proportional sides and allow us to solve a few of the problems down below. So let's go ahead and we can walk through number 3 together, and then I will turn you guys loose to try the last few, and you can watch the rest of the video to make sure you're on the right track. So this is an interesting problem. It says a farmer's land is divided by a newly constructed interstate. The distance shown are in meters. Find the distance CA between the north border and the south border of the farmer's land. So we've got our 3 parallel lines going horizontally here. We've got the border of his property here, and then we have the interstate, or I'm sorry, we've got the border of his property here, and the interstate is actually going straight through the middle. So we know that BC is, or CA is what we're looking for. So we're actually looking for this whole thing, but using our proportions, we should be able to find BC, which we're going to label X. So if we set up our proportion here, we can say that 2,000 over X is equal to 2,500 over 3,000. So if we go ahead, use our cross products here, we would have 2,500 X is equal to 6 million, and then if we take 6 million and divide it by 2,500, it will give us the value of X is 2,400. So we know X is 2,400, however, the problem wanted us to find distance CA, so we know that CA is equal to 2,400 plus the 2,000 that we had above it, so CA is actually 4,400. And all these measurements were in meters. So why don't you go ahead and pause the video, try out these last 4 problems that are down below, and then you can hit the play button again and see if you're on the right track. So looking at these bottom 4, in the diagrams, we know they're telling us that there is an angle bisector in every problem. Angles DEG are congruent to GEF. So we know here and here are congruent, giving us the ability to use the theorem we talked about up here about angle bisectors. So it asks to find DG, but we're going to find DE in this first problem. So we know that X over 18, these second sides, are equal to 5 over 15, that base that got split into 2. So here we get 15x is equal to 80 So if we divide this out, 80 divided by 15 is going to give us 5 1/3, or 5.3 repeating is going to be that missing side. Then here, if we set up this one, we're going to have 8 over 12 is equal to x over, now we don't have a value for GF, but we're given information here that's going to allow us to find GF. So we know the whole thing is 14 from D to F. We know D to G is X. We only want G to F. So if we take the whole 14 and we subtract the X that we do not need, it's going to leave us with GF. So now we've got this proportion. We can go ahead and use our cross products here. Remember, when we use our cross products for x times 14 minus x, we are going to have to use distributive property. So x times 14 is going to give us 112. Minus that 8x is equal to 12x. So if we solve this two-step problem, go ahead and add 8x to both sides. So 112 is equal to 20x. Then when I take 112 and divide it by 20, I'm going to get the value of x here is 5.6. However, be aware it wants dg, which is x, so we are good that dg is 5.6. And our last two problems here. Number 5, find the length of AB. So if we are trying to find the length of AB here, this is our unknown, we'll just call it x. We have our parallel lines, which are going to break our transversals into proportionate segments. So we know x over 32 is equal to 27 over 24. So if we use our cross products here, 24 times x is going to give us 24x. 27 times 32 is going to give us 864. When we divide 864 by 24, we get x is the value 36. So our missing side is going to be 36. And the last one here, we're missing AB, so we're going to find AB. We know 2 over x is equal to 1 over 3. X is equal to 6 here. Pretty simple problem, no division, just a one-step cross products to solve our proportion. All right, guys, if you have any questions, I will be in class tomorrow over via Zoom. We'll get those answered. Make sure you guys check out Mudge. Finish up that homework for me tonight. The key for this is also posted, so you can check your answers, and then we'll have a quick check-in tomorrow. Have a good day, fellas. I'll talk to you tomorrow.